Hi, everyone. My name is Ryan Booz. I'm a Postgres advocate with Redgate Software, and I'm a little bit behind, but starting to work through the advent of code using just SQL and Postgres 15 currently. And I just wanted to see, because others in my community, the Postgres community, have been talking about doing advent of code just with SQL. And so I'm a little bit late to the game. I don't care about leaderboards or points. I just care about the puzzle and learning. And so I'm trying to figure out how can I take this data each day, somehow parse it into a structure that I can solve these puzzles with as best as possible using just SQL and the functions provided in Postgres without creating something like a PLPG SQL function in some way, something like that. I don't know if I'll eventually have to flip over to some custom functions or store procedures. Hopefully not. So we're going to keep going. This is day 4. So let's flip over to what day 4 looked like. So day 4 was about overlaps. Now, the cool thing here is I've recently just been researching and doing some work with arrays and range types to solve some other problems, just some blog posts I've been working on, some talks I've been thinking about giving. And so I kind of had ranges in mind anyway. And so when I saw this, I was like, this feels like a perfect opportunity for doing something with either arrays or range types. And so I actually have both solutions. I just wanted to see what I could do with both. Here's the basics. We're going to get a file that looks really similar to this. Let me show you what that file looks like. So it's a set of rows. Again, I don't remember, maybe 1,000 in here, I forget. And it's 2 sets. So the first set is like there's these places within the camp. There's a grid of places to clean up as they're getting ready to head out. And there's a pair of elves. And these are all of the areas that they're supposed to clean up. And so the goal here is to find areas, these like ranges that might overlap so the elves don't do twice the work. And so this is elf 1's range, and this is elf 2's range, right? So this is inclusive of 32 to 40. And that's important because it is inclusive, right? Ranges can either be inclusive, only left inclusive, or lower inclusive, or right inclusive, or upper inclusive, meaning, it contains both the start and the end of the range, or just the start but not the ending number, or not the start but the ending number. So there's lots of ways to think about how to do ranges, but you need to know those 3 basic concepts. So in this case, it is inclusive. The numbers we're given are the starting and ending range inclusive. And really, all that we were asked to do is find how many of these ranges fully overlap. So one of the ranges is fully included in the other range, right? So the examples they give here are, let me get my little draw here. The examples they give here have 2 that are fully enclosed. So here's the first one, right? Those numbers on the bottom, 3, 4, 5, and 6, are fully enclosed within 2 to 8. This one, and then the other one is a 6, because it's the only one, it's that one area, it's that one range, and is fully enclosed in 4, 5, and 6. Overlaps that are just partially overlap like this are not part of the answer for this go around. So it's got to be fully enclosed. So I think there's 1,000 rows. Let's go figure it out. So in December, for December 4th, I created that ID column. As I've said every single time so far, I just do that because I don't know when that might be helpful, because there's no other context within the file. And so I just make it available. As the rows are imported, I'm going to create that ID column for each row. And then I just imported that tasks as a text field that I could do something with after the fact. So in total, there are 1,000 rows in this table. This is what the rows look like. It's just an ID and then a text field. That's it. The first thing I thought about is, why not just split this apart? So I need to get the first range and the second range. So split part came to mind. Just to give you an example, for every row, in fact, let me do this. ID, what did I call that? I called it tasks. And then I could do split part 1. And I think I just do this down below, but I'll do this here. And then split part 2, because I know there are 2 for each one. What should I do? Oop, tasks. There you go. So you can see that simply splits apart and gets me the first one before the comma and the second one after the comma. So those are my 2 ranges. That's what I need to get started. So the first thing I decided to try was just because I could, again, if you watch video one, I like arrays. I like the way that Postgres has all this different array functionality. I also like generating data. I did a whole bunch of videos maybe a year ago on generating sample fake data in Postgres just using functions and generate series. So I essentially did what I just showed you up here. I split them apart to get the first row, and then I created an array. So I needed to get each number out of it. And again, just for me, the easiest way to do that was to split it into an array. So I have array 1 and array 2. So I think I should be able to just do this. So if I just do that much, you'll see that what I get is for the ID column, an array with a beginning and ending range, an array with a beginning and ending range. Great. So now that I have that range, I can generate a series from, so right, so this is an array. So in Postgres, we are one based. So elf1, there's the starting of the range, there's the ending of the range, and I can generate a series of numbers from beginning to end. That's what generate series does. Same thing for elf2 over here. There's the beginning and ending of their range out of the arrays that you can see down below there. So what does that look like? Well, now I get a whole array. Now, since I'm doing generate series, I'm getting kind of a table of this, right? So the first one, it was one value, 31-31. So it's just going to return one value. Otherwise, I get nulls. You can kind of see that in the grid if I do it this way. But I get a total set of values for all of these arrays. Cool. So I'm getting closer. So now I know all of the numbers that are contained within this whole range for every single elf within each group. And then I needed to say, hey, within those task groups, actually combine these back into an array so that I can do some comparisons, some overlaps. I probably could have done this in the table, but honestly, I had those comparison operators for arrays in mind. And so I turned the column, the rows back into arrays with array aggregation. And I just said where not null, right? So if I didn't say that, let me show you what this looks like if I don't include. Let me just get rid of that, and I'll get rid of this. All right, so if I just do that, and I say select star from task groups, right? So this is like split it apart, turn it back into array, and this is what it looks like now. You'll notice that that first group, that first array, they both have 9. That's because the largest one has 9, but there's a bunch of nulls in here. That's not what I wanted. And the reason is, if I try and compare those two, let's say, let me do this, star, and then I'll say T task list 1. Is it contained in task list 2? It's not, and that's correct, but eventually you'll find there's some places that the overlap, I'm ending up with these things that all have the same numbers. The comparison operator counts the nulls as something. So now I actually don't get the answer I want with array comparison operators. And so if I add that filter back in, and I do that select star from task groups, oops. Now I get, you'll see that first one only has 31, second one has 9 elements, 60 elements, 79 elements. So I'm just getting the elements that are necessary there. And now that changes just a little bit. If I say task list 1, and that says, is any element in this array contained in this array? So now you may not have remembered from the first go around, but that does end up being a little bit different list. And that was really important to the final solution. If I didn't get rid of those nulls, the arrays, those nulls are not contained in the second array because they're different sizes, but there's no nulls over there. And so it just says, this has, maybe a value 31. I think the first one says 31, right? So if this was 31 and a whole, I keep doing that. If this was 31 and a whole bunch of nulls, the second array doesn't have any nulls. And so is this array fully contained in the other array? Comes back as false. So the filtering out the nulls is really important there. But there's one other, so I did that. And at first I just summed, I gave that thing a name. It turns out that I forgot this. right? One is this array fully contained in the other array? But if the second array, task list 2, is smaller than the first array, then I actually need to do the comparison in both directions. There's probably an easier way around this. This was just the easiest way to do that. So in Postgres, array comparisons are a couple of things. The @ symbol with the pointer says, is this thing over here fully contained in this array over here? Likewise, then you can go backwards. Is this array fully contained inside of that array? You can also do just and, which simply says, is there any overlap at all? Are there any elements in array 1 that are contained somewhere in array 2? Not all of them. Are there any? That might be useful in the next puzzle. So as long as I did it that way, for me, the easiest way to do this as I was doing this was with the case statement. So select case. When task list 1 is fully contained in task list 2, it's 1. When task list 2, I could have done this the other way, so it was both. I could have said TL2 @ symbol. I just kept it this way. It was easier to type. Is contained 1, otherwise it's 0. And I'm going to sum that up. And it turns out that there are 556 rows in this data set that fully overlap each other, either between either array set, both directions. All right. So that was the correct answer for that. An alternate for 1 was to do it this way. I realized I probably didn't have to do the array split. I also thought about range types. So Postgres has this cool type called a range type. You can actually create columns with ranges in them. And the range is just either dates or values. So the starting and ending, again, you have to be aware of, is it inclusive? Is it lower inclusive but not upper? Or is it upper inclusive but not lower? Or is it not inclusive of either the upper or lower? So there are actually 4 different ways to identify a range. Remember, in this case, it is fully inclusive. So what I did, and this might be new for some of you if you haven't done a lot of Postgres, I'll do that to make it easier to see. And then I'll just pull this out. So the format statement, we have these cool things called double dollar signs. And there's a technical name for it, and my brain's it's escaped my brain right now. Basically, within strings, anything between these $2 signs, now they're used in lots of other places, they identify the starting and the ending of a string or a containment. So they're actually used when you create functions, store procedures, you're creating it, and then everything that's contained within that starts and ends with some kind of double dollar sign. You also do this with anonymous code blocks. In this case, in the format statement, the first argument of the format statement in this case is a string. And so essentially Postgres ignores that in the final output and gets me this actual string, the brackets included. So in Postgres, square brackets, whichever side of the array they're on, or of the range that they're on, a square bracket means inclusive. So if I had done this, it would say inclusive of the lower value, but exclusive of the higher value, right? Likewise, if I had done that, it would be exclusive of the lower, but inclusive of the higher. In this case, the ranges we got are all inclusive. So if I do the inclusive, this is what that ends up. Now I still did the split part, and then I replaced the hyphen with a comma so that when I put that string inside of here and I cast it to a range, I get a range type. Here's what it ends up looking like. So I pulled everything out so that you could see it. The ID from my original table, there's the string that I did after splitting it apart and replacing the hyphen with a comma. And then I simply put that into here, and it ends up translating it into this inclusive but exclusive, right? So the range type has to have at least 2 separate values. So Postgres does the right thing in casting it to a range. So because it's in this exact case, notice they're all exclusive of the upper. So this is 31, right? It's exclusive of the upper range, 32. So it's just 31, which if you remember is what that first value was. You can see it over here, 31, 31. And then likewise, I think I lost my cursor here. I keep doing that. I mouse over and I get that little thing going. So this is 3240. Therefore, it is 32 inclusive, 41 exclusive. So that's still 3240. Now that I have a range type, I can do the exact same comparison. So it saved me maybe a little bit of effort, and maybe it's just easier to see. Range types are just really valuable for finding those overlaps. In a larger Postgres implementation, we can then do indexing on this, things like a gist or gin index on range types. So actually gist, so that you can get a better, you can actually begin to use ranges over your comparisons of inclusivity or not. And so it's essentially the same thing. Now I'm saying, hey, you have range 1 and range 2. Is range 1 fully included in range 2? Is range 2 fully included in range 1? So I just did the exact same statement and I get the same result just using range types. All right, so that was number 2. This video is getting a little bit longer, a little bit more complicated. For star 2, I did the exact same thing. I just had to change one little thing. It actually got even simpler. Notice I did the exact same. In this case, I stuck with the range types because I thought they were kind of cool and I wanted to use the range types. And the second one simply was, you know what? They realize they're doing some more work, these elves. So they really want to make sure, find all of the pairs of, those locations, all those ranges that have any overlap. So remember earlier, I told you both with arrays and ranges, the double and symbol simply means overlap. Is there any overlap between these two things? I could have done this exact same thing. In fact, let me do it really quickly up here. Even using all those arrays, remember this one was the array one where I got the part, then split it to an array, then generated the series. So I got these arrays. I could have done the exact same thing. Let me just copy it up here. It means the exact same thing. Postgres is doing the translation between arrays right? So this should get me 876. That's using arrays. I'm going to get rid of that because I don't like that up there. Down here, using the range type, and I did just hit Control Enter, so that did execute the query. To prove it to you, I will close this, execute it again. I got the same answer, 876. So there's two solutions, one using arrays, one using range types, taking that data, splitting it apart, and creating them. Again, I hope that's interesting and useful. I just wanted to share with you how I solved day 4 using Postgres and the input provided from Advent of Code. Take care. Have a great time.